A research paper from NVIDIA just became the most interesting AI paper on my X feed this week. The paper is called SANA-WM, Efficient Minute-Scale World Modeling with Hybrid Linear Diffusion Transformer. The short version is wild, a 2.6 billion parameter open-source world model that takes one image and a camera trajectory, then rolls out a minute of 720p video on a single GPU. This is not just another pretty video model, it is a controllable world model, and the important word is controllable. The arXiv page was submitted on May 14th, and the NVLabs project page says the release supports 720p 1-minute generation with 6 degrees of freedom camera control. That means the model is not just hallucinating a clip from text, it is being asked to follow a planned camera path through a scene. The project tagline is basically the thesis. One image plus a camera trajectory turns into a controllable minute-long video world. For robotics, games, simulation, and AI filmmaking, that is a much bigger idea than a short viral video. The easiest mistake is to compare this only to normal video generation. A text-to-video model gives you a shot. A world model is trying to preserve a scene while you move inside it. Watch the demos: cave interiors, fantasy forests, canyons, libraries, rain-soaked trails. The camera is not a decoration. It is the control signal. If the model can keep objects stable while the viewpoint changes, you can start using generated video as a cheap sandbox for agents that need to understand space, motion, and consequences. The technical move is hybrid linear attention. The paper says SANA-WM combines frame-wise gated delta-net with periodic softmax attention, so the model can carry long video context without exploding the memory budget. Then it adds dual-branch camera control. One branch handles global pose, and another helps the model follow pixel-aligned geometry. In plain English, SANA-WM is trying to solve the two problems that make world videos fall apart: remembering the world for a full minute and obeying the camera path instead of drifting into a random video. The efficiency numbers are the reason this paper matters. The abstract says the system uses about 213,000 public video clips with metric scale pose supervision, trains in 15 days on 64 H100s, and generates each 60-second clip on a single GPU. Even more aggressively, the distilled variant can run on a single RTX 5090 with NVFP4 quantization and denoise a 60-second 720p clip in 34 seconds. If that holds up for researchers, world modeling stops being only a giant lab infrastructure problem and becomes something smaller teams can actually test. The other important piece is the two-stage generation pipeline. SANA-WM first creates the long rollout, then uses a long video refiner to sharpen texture, motion, and late window quality. That matters because long-generated videos usually degrade. Objects mutate, geometry wobbles, the scene slowly forgets itself. The project page shows stage 1 versus refined examples, and that is the practical lesson. Minute-scale world modeling is not one magic model call. It is a pipeline built to keep long videos from falling apart. The builder implication is simple. If you can cheaply generate long, controlled, visually coherent environments, you can prototype training data and simulated experiences faster. Robotics teams can test perception and navigation ideas. Game teams can sketch explorable worlds. Creators can design camera paths instead of begging a video model to guess the shot. An AI agent builder should pay attention, because embodied AI needs more than language. It needs a way to imagine what happens when an agent moves through the world. The caveat is also important. The project page notes that the first frame images for the gallery were generated with GPT Image 2 and Nano Banana Pro, and SANA-WM animates those stills into video. So this is not a complete end-to-end world simulator yet, but it is still a serious signal. The frontier is moving from bigger video generators toward controllable, efficient, long-horizon world models. The question after SANA-WM is not just who can make the best video, it is who has the best action-labeled world data.